Touwsrivier trains and transits. But we need to go into history first and look at a little bit of history. So first there was this oak, Tycho Brahe. He died in 1601 at the age of 54. He was a Danish astronomer. It was before the telescope, but he recorded the planetary positions for 20 years. But he got stuck on this geocentric model, and he could never figure out the mathematics of how planets work. Now, he and his cousin had a duel on who's the best mathematician. So he lost his nose in the duel, so he wore a prosthetic nose for the rest of his life. He also had an affair with the Queen of Denmark, so he was banished. Now, I think he was a colorful character, but unfortunately, he could never figure it out. But he did that 20 years of very careful observations from his own observatory, and that was the key for this guy, Johannes Kepler. Johannes Kepler, he passed away in 1630 at the age of 58. But from 1600, he analyzed Tycho's work. And 9 years later, he published the first and the second laws of planetary motion. Then he spent another 10 years, and he figured the third law out. Now, all that the third law says is that there's a relationship between the period of the planet and the distance from the sun. So now we knew the relative distances. Previously, people knew this, thought they go in circular orbits, but the maths doesn't work for a circular orbit, so they were always wrong. But he came and he said, no, it's not a circular orbit, it's an elliptical orbit, and suddenly the maths work. It's close to a circle, but the maths work, and it does not for a circle. So now we knew the relative distances to the planets, and of course the relative distances is this thing we call an astronomical unit. So Earth is 1 astronomical unit, Mars is 1.5, Jupiter is 5.2, and Saturn is 9.6. But we still don't know at that point how far is it really. We just knew the relative distance. So that brings us to this oak, Jeremiah Horrocks. Now, Jeremiah Horrocks passed away at the age of 22 in 1641. But he predicted the transit of Venus in 1639. Venus going past the sun. Now, what is a transit? The two inner planets, Mercury and Venus, sometimes go between us and the Earth. And when they go up between us and the sun, and when they go directly between us and the sun, we can actually see them like that. There's Venus crossing the disk of the sun. He predicted this, and he was the sole observer in 1639. I think he had a mate that observed it with him, but he figured this out on his own. He was an Oxford or a Cambridge dropout. He was nobody in astronomy. He couldn't contact any astronomers. He did this, and 2 years later he died. His work was published after his death. And then, well, this is what he figured out. The transit of Venus comes in pairs, 8 years apart, but between those pairs there's 105 or 102, 22 years gap. So 1631 and 39, then the next one is 61 and 69, and the next one is 1874 and 82. So they're far apart. If you miss one, then you've missed it. Which brings us to Edmund Halley. We all know his name. He lived till 85. Yes,
Oh, these slides on the screen, very awesome. I'm going to see the slides.
Can't you see the slides?
No. We can't see the slides remotely.
Well, we can see them. I can see it.
I can't. Is there a setting I need to go to?
Yeah, it's just part of normal.
I can see mine.
So I think that you just need to maximize that window. There should be, I don't know what the window is called. Ed, you've got your hand up as well.
Willem, can I also say something?
Yes, please.
On your screen, there's a Willems screen. You must click on it and you'll see it. Whoever can't see the screen, click on Willems screen.
Yeah, so there's a Willem and a Willem screen. I think you need to click on Willem's screen.
Because you can click on
Yes.
anyone.
Yeah, I've got it.
Yeah,
Yes,
you can
I
click
have.
on anyone, you can see it.
Yep,
Click on
I can
Willem's
see
screen,
it.
you're there.
I've got it now. Thank you.
Okay, great.
Okay.
Right, so Edmund Halley, we all know his name. He was instrumental in getting Isaac Newton to publish his laws of motion and gravity, published in 1687. And Halley could then use these new laws to predict the periodicity of a comet. And he predicted that the comet that he saw as a child will return in 1758. He missed it, of course. But it was named after him. It came again in 1910, 1986, and it will be here again in 2061. I hope I'm making it, but probably not. So Halley then figured out how to use Venus going in front of the Sun to measure the distance to Venus. And according to Kepler's laws, if you know one of the distances, you know all of them. So he figured this out in 1716, but of course the next transit would be, he would miss that as well. But that is what a transit measurement would look like. So if you look at the Venus crossing the Sun from two different places on Earth, you will see Venus going in two different locations across the disk of the Sun. And he figured out how to measure that angle. And in other words, if you know how far those two places are apart, and you can measure this angle by using these different calculations, you know the distance. So, very smart bloke to figure this out. So then they started sending out expeditions to do this. So the first expedition, the 1761 global expedition, they went to St. Helena, to the Cape of Good Hope. Lots of bad weather, but they did a calculation and they got to 153 million kilometers. Today we know it's just under 150 million kilometers, so they weren't bad, but they knew that this was not perfect. But now we knew the true distances. Give or take, I think, 6% error at that point in time. So now we know Earth is 150 million kilometers away, Jupiter is 780 million, and Saturn is 1.4 billion kilometers. So suddenly the scale of the universe, or at least of the solar system, opened up to us. But everybody was seeking perfection. So in 1769, the famous Captain James Cook went to Tahiti. They sent other expeditions to Canada, Norway, Ireland, Greenland, but they had similar results because they made similar mistakes, because this is a difficult thing to achieve. You've got Venus coming in front of the Sun, and about 6 or 8 hours later it leaves the Sun, that's it. But then you have to wait 8 years or 122 before it happens again. Difficult to practice for. So in 1874, they sent an expedition to Egypt, Australia, South Africa, and it was the first time they were able to photograph this. But they made good sketches, and some of these sketches show us the kind of problem that they have. This is called the black drop effect. So is Venus now fully in front of the Sun or not? So it's difficult with that optical drop that you see in between. They also saw that atmosphere being backlit of Venus, and they're not sure when it actually goes across the disk of the Sun. They also spoke about a ring of light around Venus, or a halo. So getting that accurate at the moment when it touches the Sun was quite a challenge. So it wasn't as good as it had to be, and the error was similar. But then a new era came, and the new era was the railway. So in 1859, there was a horse-drawn railway from Cape Town to Wellington. And in 1862, it was steam. By the way, the Wellington farmers derailed the train because they didn't like this thing coming. Nothing new. In 1875, the railway reached Gouda, and in 1877, it reached Montetjie Road, which is today known as Touwsrivier. So the importance of the railway, it opens up the interior for this kind of scientific exploration. And importantly, it comes with a telegraph. So now they can get time signals from here. So, the next expedition, 1882, they went to the Cape Observatory. Went to Durban, Mauritius, Australia, Canada, New Zealand. They went to Aberdeen Road, which is Aberdeen today, and they went to Touwsrivier. Excuse me. This is a photograph of one of the telescopes in Touwsrivier, and there you can see it says, printed on the box, transit of Venus, Montetjie Road. These were the crates that they transported the equipment in, and they also built huts with the crates. So there's an actual photograph, 1882, taken in Touwsrivier. So they made a small contribution to that whole effort, but it was a contribution nonetheless. Now in that site in 1903, they built the Douglas Hotel, and today this is what it looks like. But behind that wall there is this, a little monument, and that is the pier that they built to put their telescope on. It is still there. At the same time, the Americans went to Wellington, and apparently the foundation is still there if you know where to look, but nothing else. We've got this left in Touwsrivier, but I'm not sure if one can actually visit. Okay, to summarize, just a timeline for nerds. So 1601, Tycho died. In 1607, the telescope was invented. 1619, Kepler's third law. 1631, there was a transit of Venus, but nobody knew about it. 1639, it was observed by Horrocks. In 1687, Newton published his laws of gravity. In 1705, Halley computed Halley's comet, and in 1716, Halley figured out how to measure the distance to Venus. 1716, they actually measured it. In 1769, the famous Captain Cook did his measurement from Tahiti. Then a long gap. In 1865, can you believe it? There was a telegraph from Cape Town to London via undersea cables. It's longer ago than I thought it would be. 1874, transit similar as than the previous one. 1877, first train to Touwsrivier. 1882, the transit in Touwsrivier, and there they got it right. I think they were out by 1%. Then in 1961, they bounced the radar of Venus, and then they knew exactly what it is. Of course, 2004, 2012, there was a transit, and that's the picture I took in 2004. I was lucky enough to observe. Thank you. That is my story. And thank you to Willie Koorts. There's a 20-something page document written by Willie Koorts on the SAO website. On the SAO or SAO website. Just ask me now. I can send you the link. It's very interesting to read. It's about the British expedition to Touwsrivier. Willie grew up in Touwsrivier, so he was interested in this. Thank you. I don't know if I know more than this, but if there are any questions. Okay, then that is it. We can have tea and coffee, and if you're at home, you can probably have a glass of wine. Thank you very much. Thank you, everybody, for a productive meeting.